It's time for understanding forces. Here's our objectives. What is a force? A force is a push or a pull that occurs between two objects. It must include two objects. Forces can't exist alone, just like the sound of one hand clapping. It isn't possible. Also, forces are vectors, which means you must include the magnitude and direction when measuring them. So how far can you throw a baseball? I'd bet my life savings you could throw it over 100 miles. And Isaac Newton would agree with me. Newton's first law of motion states an object in motion or at rest will stay in motion or at rest until another force acts upon it. And if you threw a baseball in outer space, well, it would easily stay in motion for over 100 miles. Because there aren't too many forces acting in outer space that would slow it down. Working on Earth, sometimes it's harder to visualize Newton's laws because there are so many forces acting upon objects. If you threw a baseball on Earth, gravity and air resistance would certainly interfere before the ball could reach 100 miles. Let's take a look at Alan the astronaut. He's been working on a satellite in outer space, but now his jetpack is malfunctioning. How can he get back to his spacecraft? Well, Alan can push on the satellite. Newton's third law of motion tells us that for every action force, there's an equal and opposite reaction force. If Alan pushes on the satellite will push him back with an equal and opposite force. But does that equal and opposite force produce the same result on these two objects? It doesn't look like it. This is addressed by Newton's second law of motion, which is generally written as an equation. Acceleration is equal to the net force divided by mass. This means using the same amount of force, an object with less mass will accelerate more, while an object with more mass will accelerate less. In order to use this equation, we'll need to make sure we understand the terms. Net force is the sum of all forces acting on an object, and these forces are measured in newtons. Mass is the amount of matter in an object. It's measured in kilograms. 1 kilogram is about equal to 2.2 pounds. The same force gives Alan an acceleration of 2.3 meters per second squared and the satellite an acceleration of 1 meter per second squared, because Alan has less mass. Okay, it's time to return to Earth. Sandra went shopping for a few things for her new apartment. She has to push a shopping cart across 3 different surfaces to get to her car. The first surface is the carpet inside the store. Sandra always pushes with 30 newtons of force to the right, and the carpet creates 30 newtons of friction to the left. Friction always acts in the opposite direction of motion. A plus 30 newton push to the right and a negative 30 newton of friction to the left creates balanced forces, when forces are equal and opposite, creating a net force of 0. When the forces are balanced, objects will either not move or move at a constant speed. The second surface is a gravel parking lot. its negative 45 newtons of friction works against Sandra's 30 newton push. Now the net force is negative 15 newtons to the left. If she wasn't already moving, 30 newtons wouldn't be enough to move the cart at all. Since the net force and acceleration are always in the same direction, the cart begins to slow down due to the negative net force. The last surface is a patch of ice in the parking lot. It reduces the friction to 0. That means the net force is plus 30 newtons to the right. This positive net force causes a positive acceleration that speeds her up.